He is the coordinator of our projects in BG Group, and he's going to make a presentation about new UR techniques. Thank you very much, David.
Okay, thanks, Paolo. Yeah, okay, what I thought I might do initially is just talk a little bit about the BG Fellowship Program, and that's the funding mechanism by which BG provides funding for PhD and PDF, postdoctorate fellows, for research training overseas. As you know, we've got a collaborative arrangement with Heriot Watt, and it took a lot of discussions to get things organized and set up, and eventually after quite a lot of discussions with Moran, he agreed that it would be a great idea, to try and set up a similar system here in Brazil to that they have in Heriot Watt. We're quite lucky in that, Moran has got years of experience in setting up and running a very sophisticated laboratory. And, one of the key things that you need to be able to do is to, represent very accurately what's happening in the reservoir. We've heard that relative permeability, it's really an empirical type of relationship. So unless you can replicate very precisely the conditions in the reservoir, the results you're going to get are going to be quite meaningless. So having a facility that can do that really puts you in a very good position. Anyway, before going on to the technical section, I'll just run a bit through the fellowship program, and then for the technical aspect, I'd like to talk a bit about what we're doing with other universities, with other groups, other research groups, because BG's objective here is really to funnel all of its technology requirements through our technology center here in Rio. We're building this just down the road next to Schlumberger, next to Halliburton, and it should hopefully look like that in about 6 months. It certainly doesn't look like it right now, but hopefully in about 6 months' time it'll look a bit like that. And I hope the birds don't find this too attractive as well, otherwise it might be a bit of a problem. Okay, so the fellowship program. You probably know a bit about it already, but so I'll glance through these slides. Our original objective was to try and invest up to about 100 million. We, fortunately, with our relationship with Petrobras, are the second biggest oil producer in Brazil because of the share that we have in Lula. And we, like Petrobras, have a requirement to spend 1% of our revenue stream on research. And we decided, a good way of doing that would be to split the group up into a number of different technical areas, and I look after the reservoir engineering component of the subsurface activities. And, I thought it would be great if we could set up a lab here. I've known Moran for some time, and BG's had a relationship through these GIPs, these joint industry projects, for quite a number of years, and I thought that model set up here would be an ideal thing. And also Heriot Watt, as Moran has pointed out, have got a lot of relationships globally. A new center in the Far East set up recently, and we'd hope to be able to expand the activities here for the benefit of research and development of EOR in Brazil. So anyway, we have to spend of the order of US $100 million. The plan had been around about 450 PhD and postdoctorate students. I think that's going to be a pretty difficult target to realize, because one of the problems we have in reservoir engineering in particular is that it's a very sought after profession, and a lot of people, when they get an MSc in petroleum engineering, are plucked away by industry in one way or another, and keeping them in research is quite difficult. So I would ask you, and I don't know what your objectives are, but one of the great opportunities here, I think, in Brazil, is to, get a number of entrepreneurial types, to use their skills in petroleum engineering to set up their own companies and their own businesses to address specific needs in challenging areas in the industry. And I think, what Moran was pointing out, EOR is a fantastic area to really focus on today, because there is so much oil left in the ground. People who can come up with the right ideas and the right approach could actually do very well for themselves, developing specific aspects of enhanced oil recovery here in Brazil. So I'd put that, as a challenge to you to think about, having the right kind of vision and approach, using your knowledge that you gain, through studying, to try and look for an application. Can you see a specific application that was really required, which would have a benefit? Of course, the other way of doing things is the way I guess most people go. They go and sit in an oil company and just go through the process of being a full-time employee. But there's a lot of good opportunities here, and certainly BG are very keen to promote that if possible, because we find it difficult to spend money with commercial organizations. We have the Schlumbergers, the Halliburtons, but the government really doesn't want us putting money to companies that have already a huge turnover and are making large profits. They'd much rather the money be spent on small companies that are developing here in Brazil, spin-off companies. So, there are many opportunities, I think, for people in the petroleum engineering to go down that road. So I would hope that, a number of people here would end up choosing that pathway, because it certainly keeps you in contact with BG, because we can help fund people like that eventually. And I think it also gives you a lot of drive and determination if you have a challenging goal to drive you, right at the outset. Okay, so that's the fellowship program. Science Without Borders, I guess, was designed by the Brazilian government to provide skills that weren't necessarily well developed here in Brazil, and to give Brazilian students an opportunity, to go overseas. And I think it is a great opportunity to actually work outside of your own hometown, as it were, and to get experience in a different culture, teaching in a slightly different way. And at Heriot Watt, I know they have a very, very good system over there, and I'm hoping that eventually we will get a good exchange, sandwich exchange between Heriot Watt and UFRJ set up. It is challenging finding students, though. We thought it would be a lot easier to find students for this program, but because of this problem of retaining people in research in this area, it's proving to be a big challenge. But hopefully, word will get out, and we'll get the numbers up over the next year or two. Obviously, the Science With Borders is coordinated by a CNPq, and we have quite a good system set up now. I think it's quite a good package that's offered, and I won't go into it here. The website that was pointed out by Paolo at the start gives all the information there if you're in doubt about any of the aspects of how the funding works. So what can and can't be eligible? Looking down here, for Brazilian nationals, that most things can be supported. Going internationally, we can't send undergraduates overseas. I mean, I think there are a number of foreign nationals who are working here, and unfortunately, we can't send them to Heriot Watt under the scheme, because you have to have permanent residency here in Brazil, or be a Brazilian national to qualify. So for international students working here in UFRJ, the training has to be done entirely here in country. So what is a fellowship? What do you get? Well, obviously there's a scholarship. There's university fees are paid for in the UK, and they can be quite expensive. Unlike Brazil, where the government pays the fees, most countries, apart from I think Norway, maybe one or two others, the fees are have to be paid, and BG will pay all of those fees. It will also provide additional money for the supervisor for travel and subsistence to go to the hosting institute, in this case Heriot Watt. Associated training costs, national and international conference attending. There's payment for that, and I think there's also a laptop computer provided. So the overall package, I think, is quite good, and the main benefit, as I said earlier, really is the opportunity to live overseas and experience a slightly different culture. So the duration is typically 4 years. Postdoc training is typically 2 years secondments. And the benefits, it's obviously collaboration is one of the main things. We want to attract the best students in Brazil. And I think, as I tried to point out right at the start, Harriet Watt has got some very specialist skills in EOR. And by having the lab here, it allows us, to utilize the facilities at Harriet Watt, because it is an expensive business putting a student into those labs. I mean, the running cost of those labs is very high. I mean, it's not like a small chemical lab that the chemical costs, etc. You've got a lot of equipment, a lot of investment up front for that equipment, and competition for use of that equipment. So by having this relationship, having an EOR lab here and one Harriet Watt, it gives us that opportunity, to send Brazilian students over to Harriet Watt and for them to use that equipment there. We've been through the funding, really. So, and that's the fellowship website. So, Paolo's got a reference to that. So if you haven't seen that, do have a look at it, because it has a lot of the details. And if you have any other specific questions, you can always come back to me or to Tom Watling, my colleague, and we'll try our best to answer your questions. Okay, so before going on to some of the research that we're conducting with Harriet Watt and elsewhere, I've got a question for you. Of everything we've heard today, what do you think is the most important thing that you need to address? If there was one thing out of what you've heard today or about what's going on in the industry, what would you say that was? Has anybody got any views on that? Any particular technical aspect? Okay, well, the single most important thing, in fact, is safety. And what we're doing here is a top-down approach, because we're bringing some sophisticated equipment and setting it up here. We're not starting down, training people, and then bringing in the equipment later. We're going to plonk this equipment here. And what we're putting here potentially is a bomb. And also it could be poisonous fluids you're going to be dealing with. So safety in the industry is extremely important. I mean, I started my career in Schlumberger. I had 8 years as a field engineer. And it was drummed into me right at the start that safety was absolutely paramount. And you just have to behave in a certain way. And with Schlumberger, if you didn't behave that way, you were shown the door. You have a driving accident, it's your fault, you're out. If you do something on the rig and you have an accident, even to yourself, never mind to others, you're out. As simple as that. So you have to have the right approach. And this equipment is potentially lethal. I mean, you don't have to be paranoid about using it, but as long as the right safety operational procedures are in place, and there will be before anybody uses the equipment, and that's fine. The last thing that we want to have is anybody injured. And the oil industry in particular takes puts a huge focus on emphasis on safety. And it just takes one accident to completely destroy the reputation and to ruin all the good work that's gone into setting a system up. So please bear that in mind, the approach that you take. I mean, I have been in here a few times, and there's a lot of things being set up here. So there's a lot of clutter. There's a lot of opportunities for slips, and falls, and trips, and also you have some machining equipment. And I did pass by once and notice people using the drilling machine without safety glasses. Just shouldn't happen. You might do it 10 times, you might do it 20 times, and then one day you get something in your eye, and that's irreplaceable damage. So it is the attitude, and working with the industry, things will have to change. There will have to be a very, very significant focus on safety. And this was one of my, and certainly we've discussed it in BG internally, one of the big concerns about bringing this apparatus here. I mean, in Harriet Watt, we normally don't let undergraduates touch this equipment. It's trained postdocs, and they're drilled in the way in which you operate the equipment. So we will be putting together a very detailed HS&E program, and having people skilled on that, because we just can't afford to have any mistakes in a university. It would be even worse for us than having a mistake on an operation that we've got, say, in Kazakhstan or whatever. If we injured somebody here seriously, that would be really, really bad news for us. So that's the number one criteria. Anyway, I've gone on enough about safety, so let's move on. what I've done here is we've got a relationship with the AEC, which is the Advanced Energy Corporation in the USA, which was a system that was set up by the Bureau of Economic Geology in Houston and in Austin, in Texas. And they decided to pull together a number of universities, top universities in the US, and they had four different themes. But the one I really want to go on about today is nanotechnology. Again, we talked about the importance of having a system that you can set up that can replicate what's happening in the reservoir. So we'll have the ability here in a couple of years' time to have large core samples in an environment which is just as though it was in the reservoir. Before we do that, we'll have to make sure that we prepare the core and try and put it back in exactly the same state it was when it was taken out of the reservoir, and then we can carry out experiments. And we can look at different techniques, WAG, SWAG, or whatever, and see what kind of recovery we've got. But again, that's really a top-down approach, because you're applying ideas, generalizations from Darcy's law to that rock. And okay, you're representing it very accurately, so you're fairly confident that that's what's going to happen with this particular type of rock in the reservoir. So we can build some empirical relationships which are reliable, which is great. It's better than looking at some of those other correlations that actually are pretty meaningless. But the other way we could look at it is from the bottom up. And nanotechnology now, and with some of the latest techniques that are available, really is starting to make significant progress. And I was really surprised by some of the progress that's been made by some of these research projects in the US. Looking at the nanoscale, we talk about petrophysics. I was saying to Paolo yesterday, there's not much physics in petrophysics. It's correlations, empirical relationships. The physics is really going on down at the nanoscale between the molecule and the mineral. And we're trying to look at that on a number of different ways. And I've sort of listed some of the things that we're doing here. And I would be very interested in trying to develop nanotechnology here in Brazil as well. There's quite a bit going on at a number of institutes. In fact, we have one professor who's in the AEC system, Miranda Catano, I think it's Miranda Catano, down at UFA-BC. And he is more on the theoretical side and doing theoretical modeling of molecular interactions. So that's right down on the fine scale. There are others who are doing work using AFM, atomic force microscopy, and a whole range of other activities. In Rice, they're building specifically designer molecules on nanoparticles. And let me run through this, and I'll come up to it, and I'll talk a bit more about it at that stage. So here's a list of things that are going on. We've got synthesizing high mobility nanoparticles for advanced soil recovery. As well as trying to get EOR, we're also wanting to be able to improve the reservoir characterization, illuminate the reservoir by, instead of just using existing logging technologies or seismic technologies, is there anything we can put in the reservoir which can help us identify more accurately what the distribution of the different zones are in the reservoir? So that's another area. Design to control stability of imaging nanoparticles and interactions with mineral surface. One of the big problems in using surfactants and polymers in the reservoir is that quite often they get mopped up very quickly. You inject them in the well site and they just get absorbed by the rock. They stick to the rock surface and then they don't really penetrate where you want them to go. So that is something we're looking at with nanotechnology. Can we reduce these interactions that are taking place between the fluid and the rock at the nanoscale and only allow them to operate where you want them to operate? For example, if you want EOR, you want them to go to where the oil is located and change the wettability at that location and release the oil. So if we can do that, we could probably reduce the amount of material and the cost. And it's the cost which obviously is the limiting factor for applying this kind of technology to a reasonable level where it could be economic, to use these techniques. So what else have we got? Modeling work from interfacially abstracting in silica nanohydrates. We've got measuring and modeling of nanoparticles, mobility for advanced soil recovery, integrating and applied studies of nanoparticles to probe reservoir rock, flow and particle transport in submicroscopic models of reservoirs. We've got a number of modeling applications that are being looked at, both in the US and there's one group in France is involved in that work as well. Pore and upscaling modeling work, relating the transport behavior of nanosensors and geological formations. So we're looking at trying to make mini sensors, molecules that can go in and only react where perhaps there's an oil-water contact, and then be produced and try and back calculate where that happened, to give you information about the saturation distribution in the reservoir that you wouldn't get from, say, a dumb tracer, which it's either you detect it or you don't. If you can actually get something back which has changed and give you some information about the saturation distribution, that's a new way of learning about fluid distribution in the reservoir. And then nanosensors for reservoir management. One of the things we're looking at doing here in Brazil, and in the AEC we've got a number of partners. Petrobras is a partner, we've got BP, Shell, Statoil, and Schlumberger is the only service company involved at the moment. They used to have Halliburton and Baker, but they decided to pull out. So we're looking at trying to develop either magnetic or dielectric nanoparticles which we can inject into the reservoir and then detect perhaps at a neighboring reservoir, or improve the detectability in a larger zone around the reservoir to give us more information about the fluid distribution and the fluid pathways. And we're considering, there's an old site down at Rio Grande do Sul, which used to be a fertilizer storage area, and there was leakage, so there was environmental damage to the neighboring field and water system. So a company called Newfields was given the job of trying to clean it up and also monitoring. So we have a brownfield site in that location that could be ideal for doing some small-scale testing. It has infrastructure and it has some small wells, and so we're looking at the opportunity there for trying to do some investigation of on a small scale of using magnetic and dielectric nanoparticle agents. So the objectives, magnetic contrast agents with low absorption and high mobility is required, because we need to get them into the reservoir, and we don't want them being mopped up right next to the well. So we have to try and control the mobility. We have to keep the synthesis cost low, so they've got to be we're either going to use water or TEG, because it's triethylene glycol, because it's relatively inexpensive. It's a combination of material chemistry, grafting polymers to magnetite cores to find particles with high mobility. So we can get the magnetic particle, but then we want to coat it in such a way that it won't get adsorbed onto the rock surface, and it will migrate through the reservoir. And then we can keep the unit cost lower. So we want an order of magnitude lower adsorption on this model silica that we're using, and the groups working on this have made a lot of progress in reducing the adsorption. The other problem that they had, in fact, it's interesting to see how technology transfers. A number of these guys used to work in the pharmaceutical industry, so they've been applying drug technology for that's been used in the past for targeting, say, tumors, so you only want the cancer cells identified. So they've been using their ideas, but trying to transfer that into the oil industry. And one of the major problems they've had is that the human body's a lot more benign than a reservoir. So they've had to get products which could survive very high salinities. So they were given a target of using an API brine as a required salinity level, and also temperatures up to 100 degrees Celsius. And for 2 or 3 or 4 years, I'd say about 3 years, nothing much happened. There was just a lot of chemistry going on in the lab and not much success. And then all of a sudden, it's like evolution. Suddenly there's some success, and then there's a whole raft of products start getting produced. But they're still relatively expensive, and the idea is to try and work further and reduce the amount of and quantity that you require to make this an economic and viable type of technique. So I think we've covered that. So the other question is, can these nanoparticles fully sample the reservoir? We want the mobility high enough so that they can travel between wells, and we can hopefully, get a good distribution throughout the reservoir, so that we can get more information about the way in which the fluid is flowing, and also about the saturation distribution. This is one product that's being developed at one university in the US, and they're using an iron oxide base, a basic nanoparticle, and then they're stitching these polymers onto it. And these polymers reduce the amount of absorption that you get when you inject them. But there are problems, obviously, with polymers. You've got to have the complication of getting them into the reservoir without damaging them, much more fragile than just a basic surfactant chemical. So that you've got to consider, how you're going to pump them. The high shear rates and things like that can be a problem. So there's still a number of technical challenges which need to be overcome. But there is, some very interesting new possibilities opening up here. And then what we could do with having the EOR lab, if we get some of these products that look promising, we can test it under actual conditions in the lab. So we can have a bit of core in exactly the same conditions that the reservoir is going to be applied to, and then we can see how successful or otherwise they are. We might do one type of development scenario, say a WAG technique, and then you might later on want to try one of these nano products to see what improvement you can get. Or if we're thinking of using sensors like iron oxide or some dielectric, we might want to develop some small-scale tools so that we can observe the migration of these particles through the core under reservoir conditions. So I think there's some very interesting areas of research we could do. And this is, as I said, we're looking at more of a bottom-up approach, trying to look at all of the physics that's going on right at the nano level, and developing new ideas about how we can make products more intelligently, to apply in the industry. That's, I guess, what we're saying here. The interaction of nanoparticles and minerals. We've tried a number of different interactions have been tried, but primarily with fairly clean, benign sandstone, and some sandstones with a little bit of clay content. But there's a huge amount of research that needs to be done, examining a whole spectrum of minerals and interactions, and doing all of building up a new database of how these interactions take place on the nano scale. So I think that there could be many years of interesting research in nano research, and having a facility here which can replicate the reservoir is a good way of testing how efficient some of these new techniques might be. This is this atomic force microscopy is being used, where you basically have a nanoparticle on the tip, and then you look at the interactions with the mineral surface, so you can actually physically measure the forces of interaction at the molecular level. So we could do this for a whole range of different surfaces and different types of nanoproduct to build up a kind of pattern of what those actual intermolecular forces are. So an overview of the project, we've got a micro scale, we've got the AFM, we'll have a micro model, we'll have CT scanning, and the CT scan, as we saw yesterday across the road, is very good for modeling detailed pore space. It's not so good, though, if you want to have dynamic experiments at high temperature and high pressure. You can't really do that in a CT scanner. And also the resolution is perhaps not... wouldn't be as good if you start injecting fluids into the rock. So it's very good for building that detailed map of the pore space, but what we're hoping to do with some of these new techniques is to build up a relationship of what exactly is controlling the wettability. Could you then, having this framework of pore space, stitch on the actual force mechanisms which are controlling the flow of molecules and interactions of those molecules in the rock itself. it's all very well having, you know, a poor map and digital rocks, but if you don't actually have the physical model of what's happening, you know, you're never going to be able to say much about the wettability, which is absolutely key, you know, for recovery in the reservoir. So I think linking these things together through this type of research could be a very interesting area going forward. So this slide here gives you a kind of overview of the different pieces of equipment that are being used. We've got the AFM, we have micromodels, we have CT scanners, you know, we have grain packs, so we can have a small cross section and inject these fluids and see how they move through the sand pack. And then we've got to try and upscale all of this and you know, come up with a reservoir scale model that's reliable. And that's, you know, there's some huge challenges there, but I think there's some very interesting new areas of research which we can get into. So, you know, the mobility is a key element that we're addressing in a number of these experiments that are being carried out with these US institutes. So we're trying a number of different types of coatings, and there's a couple of labs are being used over there for some basic column tests, but none of them are using the kind of reservoir conditions that will be able to replicate in the UR lab here, or that we can do in Heriot-Watt right now. So I'd be very keen to try and get some of these nanotechniques, you know, applied under reservoir conditions and see exactly, you know, what kind of benefits we can get out of them. So we need to, you know, develop techniques, polymer surfactants, to enhance nanoparticle mobility, and again, we need to look at the effect of heterogeneities. We've barely scratched the surface, really, in research in these areas, and even at Heriot-Watt, with, you know, the advanced equipment, there's only a certain amount that you can do in a given amount of time. And these experiments take a long time to carry out. Some of them take months, and you've got quite a lot of time of core preparation. So by doubling the number of facilities, having a same setup here, this will make it much better. And there could be opportunities for expanding even on a bigger scale. You know, looking at the number of developments that are likely to happen in Brazil over the next decade, there's going to be huge demand here for these type of sophisticated core measurements, and I could see, you know, the requirement for a network of these type of facilities in Brazil to satisfy that demand. And I don't think there's anybody can do these kind of experiments here in Brazil at the moment. I mean, I know Petrobras have got some sophisticated equipment. They've got a new 3-phase facility, but it does nothing to tell you about the saturation changes. They don't have an X-ray scanning facility, which will be set up here. So I think that you know, if you're getting a new building, eventually there'll be scope to expand the program that we've got here by quite a large factor. And then, you know, we want to be able to have the mathematical models. So we want to develop all of the want to have the theory to go with some of these very, very detailed experiments that we're carrying out, and stitch all of these things together so that we can eventually, hopefully, you know, from the bottom up and the top down approach, to get the two to merge together, so you have a very comprehensive physical description of what's going on at a very, very detailed level, and be able to relate that to what you measure at the macro level in a core under reservoir conditions. I mentioned that the nanoreporters is basically where you're building up a molecule which has components. It's like you have joined these various components. You've got you're covering in polymers so that you can improve your mobility, and then you want these things to react, you know, with an oil-water contact, and then these start to be released, and then you get the sensor molecule back at the production well, and by seeing exactly how it's changed, you can get some more information about the saturation distribution in the reservoir. So that's quite an interesting area of research that's going on in one of the US universities. Unfortunately, I can't really say too much because this is actually proprietary stuff from these universities. I can't mention who is carrying out this work at the moment. So the advantages of using these techs over normal surfactant flooding is that we hope to have cost-effective methods which can improve enhanced soil recovery in the future. This slide is really just showing some historical data on the normalized oil saturation and how it's related to the capillary number, and there's going to be a large range of different rock types coming out of the pre-salt, and I hope that we eventually will be able to get GIPs run here and UFRJ with maybe BG and Petrobras and maybe some of the other partners. Gulp, I think, are also involved. And in that way, we can get additional funding coming into UFRJ to fund the lab, because running this lab is not cheap. It's expensive. So we'll need to get a number of these GIP fundings, which have been successfully developed by Harriet Watt over a two-decade period now. It's a very, very successful business model to get industry involved and to fund the equipment. Okay, well, we're developing nanoparticles which have different, either hydrophobic or hydrophilic properties, and we're basically trying to create designer molecules which can be used for EOR and are cost effective. I mean, it hasn't been done yet. It's still far too expensive. The unit costs of the products which have been made to date are still too costly, probably by at least an order of magnitude yet to be of significant value. But a lot of progress has been made over the past 3 years in improving the mobility and then increasing or decreasing the amount of absorption. So I think in another year or two, there could well be some new products coming out, and it would be very good, to try and get some of these techniques done here in Brazil, and to manufacture these products here at Brazilian institutes, and hopefully, to get some spin-off companies coming out of some of the institutes to really focus on these areas. Transport behavior. Again, this one is really more of a theoretical modeling project that's been carried out. And one of the problems you do have when you go to modeling at the molecular level is just the amount of computing horsepower that you require. It becomes extremely difficult to manage all the computations and permutations that could take place at the molecular level. But with the development of supercomputers and the way in which that's changed over the past 4 or 5 years, it's becoming much more realistic, actually, to make meaningful theoretical models purely on a mathematical basis. So I think 4 or 5 years from now, the capacity in Brazil will be very, very significant. And BG's also, we've been talking with IBM as well, and IBM have got a lot of experience in nanotechnology, and obviously they've got a lot of good computing facilities. So there could be some opportunities for trying to link up with IBM. But it's much easier to actually get funding for small companies. And one of the problems we've got is getting funding with a large company like IBM is not really what the government wants us to do here. They want us to sponsor small companies and develop the skill set here, and that's as I said at the start, if we see some developments of spin-off companies in Brazil, it will give a lot more opportunities, for funding from BG, Total, Shell, or whoever's involved in pre-salt developments. That's really just sort of, again, showing what's happening with this multi-scale approach. We're trying the theoretical modeling, we're trying measuring forces at the molecular level using an AFM, we're using micromodels, and then we're working up, to build chemicals which we can test in the laboratory. So there's a whole range of different areas that we're looking at, and we're trying to join all this information up to come up with new ideas and new solutions for EOR. That's, again, this is just looking at measuring the measuring the interaction between molecules and a particular type of substrate, and this is done on a purely on a mathematical computational basis. We've got some nanoparticle. We've got some micromodel projects with an institute in France that is part of the AEC, and putting all these things together, what we could look at in Brazil. One of the useful tools you need for looking at a very, very, very small scale is synchrotron, and there's a synchrotron facility in Sao Paulo, which we'd like to be able to get research linked up with that, and I know that the government are very interested in trying to get research pumped through that. Then we'll be looking at micromodel fabrication. We were looking at some of the things that are done here yesterday. Get some micromodel experiments. We'll have one that's being set up by Harriet Watt. Reservoir simulation of nanomaterial transport. We'd like to be looking at that and using the facilities here at UFRJ. Molecular scale modeling. There's a whole range. Each one of these is a big subject which you could spend a lot of time talking about individually, but that I hope has just given you a kind of flavor of some of the other activities that BG are involved with on EOR. We're interested in trying to bring a whole range of expertise into Brazil, and we need people such as yourselves to really help in the development, and I hope that there'll be a number of you who will stay in this particular field of research, and help to develop some of these new areas for EOR going forward. Anyway, I think I'll shut up there, and if you have any particular questions, I know you've been kind of we've thrown a whole bunch of things at you all morning, and it probably is, you've more than reached saturation point. But if you have any particular questions that come to mind now, please fire away.
Very much, David.